Very good morning to all. Okay, I welcome you all for this today's our subject lecture, industrial hydraulics and pneumatic. Okay, so in the last lecture we were discussing about the pneumatic actuators, and also we have gone for the its classification. So through that classification, came to know that pneumatic cylinders are classified into two groups or two categories. One is the linear motion or linear pneumatic actuators, and another is the rotary actuators. Getting it? Now, these are the linear. Okay, I will share that now. Linear actuators. No, so it is also called your pneumatic cylinders or air cylinders. Getting it? And we have gone for the. It's a discussion about the each and every that air cylinder. That means the based on the cylinder function, that is single acting air cylinder we have seen, then double acting tandem cylinder we have seen. Getting it? So this one, okay, just I am taking the revision on that. Single acting air cylinder we have discussed, then this double acting cylinder we have discussed, then also we have discussed about this telescopic cylinder also, okay, which is used in the dumper or the tipper application. Okay, and limited rotary motion actuator, pneumatic actuator, or you can call air actuator. So about that again we have seen this rotary actuator. Okay, then we have gone for the dual piston type, that is a rack and pinion type rotary actuator. Okay, so up to this point we have covered in the last lecture. Now let us come to the another category of the pneumatic actuator, that is a rotary actuators. Okay, also it is called air motors. Okay, as we have seen in the hydraulic actuator, there also rotary actuators was there, and it is called hydraulic motor. Now here in the pneumatic section, for the pneumatic rotary actuator, it is called air motors. Getting it? Now we'll go for this part. Okay, now before proceeding to further point, just tell me whether my screen is visible at your end, whether my voice is audible at your end. In the chat box you can write your message yes, no, so that I can move further. All of you, please give me reply in the chat box. If everything is okay, then okay, I got message. Now the first basic question is that what is meant by this air motor. Okay, so we know that the function or the purpose of this air motor, please remember, rotary pneumatic actuator or air motor, okay, both are same. So the function of this air motor or function of a pneumatic rotary rotary actuator is to convert your pressure energy, that means your hydraulic energy of your fluid, and here fluid means what? Air, compressed air. So to convert the pressure energy of your compressed air into rotary mechanical energy. Okay, pressure energy of a compressed air is going to convert it into the rotary motion, and that rotary motion actually it is mechanical energy, and that through that rotary motion the useful work is going to obtain. Getting it? So the purpose or the function of this air motor or the rotary pneumatic actuator is to convert pressure energy of the compressed air into rotary mechanical energy. Okay, and for the air cylinder or the pneumatic cylinder, the function was to convert the pressure energy of a compressed air into linear mechanical energy or linear motion through which you can obtain useful work. Getting it? So same function is there, but the whatever motion you will get at output of your actuator, here is that is a rotary motion. Okay, based on that only the actuators are divided into the two categories. One is the linear and second is the rotary. Getting it? Now, like our hydraulic motor, these air motors can be classified based on their degree of angular momentum. Okay, because we know that in the hydraulic motor also, based on the degree of angular momentum of that rotation or that momentum, there also we have seen that there were two types. One is the continuous rotary and second is the limited rotary or limited rotation. Here also in the air motor we have again two types. One is this continuous rotary air motor, okay, and second is the limited rotation air motor. Okay, once again I'm repeating, like hydraulic motor, these air motors can be also classified based on their degree of angular momentum. Getting it? Sorry, a movement, not a momentum, movement. Getting it? And which are that two types? One is the continuous rotary air motors. Okay. Now further, this continuous rotary air motor again classified into the three subtype. Which are that three types? One is the gear motor, second is the your vane motor, and third one is the piston motor. Continuous rotary air motor again classified into the three type. First is the gear motor, second is the vane motors, and third is the piston motor. And second one, this limited rotation air motors. Now this category of the air motor again classified into two types. One is the vane type and second is the piston type. Getting it? Same classification we have seen in the hydraulic motor also. Okay. Now once again come to this first one, that is a continuous rotary air motor. Okay. Now, actually, these air motors with unlimited angle of rotation or even up to 10,000 revolution per minute means 10,000 RPM. Okay, so that much it is possible to get unlimited angle of rotation. Okay, with using this continuous rotary air motor, and these types of air motors are widely used to provide very high rotational speed. If you see 10,000 RPM, that is a big quantity. So that much RPM, unlimited angle of rotation, we will get through this continuous rotary air motor. Due to that only, these air motors are most widely used to provide a very high rotational speed. Getting it? And the construction, please, please note that the construction and the operation of this continuous rotary air motor are very much similar to that of our hydraulic motor, which we have discussed in the unit number 1. Getting it? Now, talking about the subtypes: gear motor, vane motors, and piston motor. Okay, in within two line, I will just give the that gear motor. Now, the gear motor, in the gear motor, what are the rotary motion is there? That is actually that rotary motion is produced by the unbalanced pneumatic force. Okay, now on which that unbalanced pneumatic force is going to apply? So that unbalanced pneumatic force is going to apply on the gear teeth. Okay, from where you will get the pneumatic force? Through the your pressurized or the compressed air, which is going to come inside that your that air cylinder. Getting it? And due to that only the force, or due to that only torque is going to produce, or torque is going to generate it. Okay, by the that pressure of the air. Okay, and that pressure of the air will be against the teeth profile of the your gear motor. Okay, of that two, because we know that the in the gear motor will have the two meshed gear. Okay, so I will explain that gear motor here itself, so that for this vane type air motor will come to back. Okay, see here, this is a schematic diagram of gear motor. Same diagram we have seen in the hydraulic motor. Okay, there also this type was there. In the pump also gear pump was there, same. So you can see here, here is our body, gear body, and through this inlet port, high pressure fluid is going to come inside of that, inside this motor. Okay, so this is inlet port. Through this high pressure fluid will come. So here fluid means what? Your compressed air, and due to that pressure of this compressed air, force is going to, or pneumatic force is going to act on this your first gear. Okay, and that first gear is already meshed with this second one. So first is the drive gear and this is the idle gear. So due to the force of this gear, this first gear will rotate clockwise. You can see the direction of this first gear, and when this first gear will rotate due to the pressure, that pneumatic force of the your compressed air, no, that time this idle gear also rotate, because this second idle gear, it is meshed with the your first one. Getting it? So first gear will rotate in clockwise direction, and as that first gear is meshed with the, your second idle gear, due to that only the rotation motion is going to pass to the second one also, that your idle gear, and due to that only idle gear also rotate in anti-clockwise direction. So you can see here direction. Okay, the first gear is rotating in clockwise direction, and this second one is rotating anti-clockwise. So due to that only the rotational motion is going to produce at the outlet of the shaft of this gear motor, and fluid will go out from this port. Okay, so at inlet you will have the fluid with the high pressure, but when it is going to out of, or when it is discharged from the your gear motor, that time the pressure of that fluid or the pressure of the air is going to reduce. So due to that only here I have written, it is a low pressure fluid is going to out through this port. So these are the this is a your outlet or the discharge port or exit. Getting it? So same construction operation we have seen for the gear hydraulic gear motor, also gear pump, and here I have explained for the our gear motor, air motor. Getting it? So this is a continuous rotary air motor, gear motor. Getting it? Understood? Understood or not? Here rotary motion is produced by the unbalanced pneumatic force. That pneumatic force is going to act on the your gear teeth. Getting it? And due to that only torque is going to generate by the pressure of this air. Okay, and that pressure will be against the teeth profile of the your this two meshed gear wheel. Okay, so this is a simple construction, working and operation of the this gear motor. Understood or not? Please tell me in the chat box. Understood or not? Understood or not? Please tell me in the chat box. Understood? Nobody's giving reply. Only one student. Understood or not? Simple construction is there. If question asked for the hydraulic gear motor, same construction will be there. But only difference we know that the air. Here air is your fluid, and in the hydraulic section we'll have that liquid or the oil. Getting it? Otherwise everything is similar. So this is the first type of the continuous rotary air motor. Okay, now the second is the vane motor. Okay, now that vane motor, again that vane motor is will come under your continuous rotary air motor also, as well as limited rotation air motor. Okay, now that vane motor means what? In that vane motor, okay, what are the rotary motion is there, no? So that will produce through that vane. Now in that, in the vane motors, what are the pressurized air is there, no, that is acting on the vane, okay, and that cause further rotate, okay, and due to that only it is developing the torque at a output, getting it, and by the that torque which are producing at the outlet, due to that only will get the rotary motion. Okay, in detail I will discuss. Okay, but before that, again I will discuss about this piston, this, okay, that radial piston type. We have another type, uh, axial piston type motor. That are that two, radial piston motor and axial piston motor. That type also we have seen for the hydraulic motor also. Okay, so construction working for this also piston type, radial or axial piston type motor, for pneumatic and your hydraulic, everything similar. But in one line I can say piston motors are the positive displacement motor. We know that piston motors are the positive displacement motors, okay, which can develop an output torque at the shaft only. Okay, out torque is going to produce output torque, that means the rotary motion it will produce at the shaft only. Okay, how? By allowing the by allowing that pressurized air, okay, to act on the your piston. Okay, so you can see here, this is a radial piston type I have shown. Okay, another is the axial piston type that we have seen, this one also. So you can see from this port you will get a fluid inside the your this piston motor. Okay, and the which the this pressurized fluid which is coming inside from this port, no? So due to that only uh, it will allow to act on this piston. This pressure is going to act on this piston. So here in the radial piston motor, you can see here we have the piston number 1, 2, 3. So fluid will come to this side of your piston. Okay, and due to that only your piston momentum will happen. Getting it? For the these three piston, and due to that only the shaft, this you can see here we have the uh, cylinder block, and this is your rotor. So due to that only this shaft will move. Okay, and once shaft will move in a rotary motion, no, that time output torque will generate. Okay, output torque will be generated through that rotary motion. And you can see here outlet, fluid outlet is shown. Okay, so that is a, this is again a continuous this type of piston pump. It again belongs for your continuous rotary air motor as well as the limited rotation motor. Okay, now limited rotary rotation air motor. Okay, so this limited rotation air motor normally it provide rotary output motion over a finite angle only. For continuous, unlimited angle of rotation you will get, but here finite angle of rotation will get. Okay, and here actually in the continuous limited rotation air motor, no, the standard rotation of the shaft of this air motor are normally 94 degrees there, 184 and 361. These are the standard rotation of the shaft, and that will get through this limited rotary air motor. Again, please, I will tell that limited rotary hydraulic motor also we have seen the our unit number 1. Okay, and what are the construction working of the limited rotation air motor, hydraulic motor we have seen there. Same construction working is applicable to this also. Okay, now come to the this vent type air motor. Okay, come to this vent type. Okay, once again I am repeating, Okay, please remember, these air motors are the rotary pneumatic actuators. Okay, or you can call these are the pneumatic actuator in the rotary actuator. Air motor, you can call it as a rotary actuator in the pneumatic system. Okay, and they transfer your air power, that means the pressure energy, into the rotary motion. Okay, and these pneumatic motors have been found for very high rotational speed. Okay, as I mentioned that 10,000 rpm, that much high rotational speed you will get through this air motor, and even more than that also it is possible to get that rpm. Okay, and due to that only these air motors are replacing your conventional motors. You can replace by this air motor. Okay, why? Due to the various inherent advantages are there. Okay, that we have discussed the advantages, okay, of the pneumatic system. And please remember that these air motors uh, uh, are having the various types or the designs. Okay, that types I have discussed, that vent type, then piston type is there, gear type is there. Okay, but please remember that the most common type of the air motor which are used now, so that type means the your vent type air motor, axial piston and radial piston type. Okay, that are most commonly used air motors. Please remember, vent type air motor, piston type air motor, and sorry, in that piston type, radial piston type air motor and axial piston type. Okay, and there are again we have the other type, but most common type means the these types. Okay, now first now let us go for this construction operation of this vent type of air motor. Okay, so for that only I have shared this diagram of the vent type. Okay, now see, this is a typical this figure is a typical vent type air motor. Okay, it is that is I have shown in this figure. Okay, please look at on the screen. And this type of vent type air motor normally provides rotation in one direction only. Please remember, this type of vent type air motor provide a rotation in one direction only. Okay, and here the rotary element is there, no? Okay, actually that is a slotted rotor. You can see here we have the slotted rotor. Okay, so this is a vent. You can see this is a vent, and this is a vent guide. Okay, vent is there, vent guide is there, and this is a inlet port through which fluid is going to come inside, or air will come inside to the your this. Okay, air motor, and this is your vent. This is a vent guide, and here we have the position number 1, position number 2. Okay, this is the inlet side, and this is the exhaust side. Getting it? So once again I am repeating, rotary element is your slotted rotor, and which is mounted on this your drive shaft. This is your drive shaft. Okay, so this slotted rotor is mounted on this drive shaft, and each slot of the rotor is fitted with the freely sliding rectangular vent. You can see here we have the freely sliding rectangular vent. Getting it? And this rotor and the vents are enclosed in this housing. Okay, this rotor and vent are enclosed in this housing. Getting it? And the inner surface of which it is offset from the drive. Okay, this inner surface is offset from your drive shaft axis. Okay, you can see this is offset from your this drive shaft. Getting it? And please remember that when this rotor is in the motion, that time this vane tends to slide outward. Okay, why it is going to tend to the outward? Because due to the centrifugal force. Once again I am repeating, when the rotor is in motion, that time the when this when is there, no, that trend tends to the slide outward due to this your centrifugal force. And this distance this when slides, no, that is limited by the due to the this shape of the rotary house. Getting it? And this rotor motor, actually this rotor, this vane type motor, actually this operate on the principle of the differential areas, because the area is going to change. Okay, see, when this compressed air is directed into this inlet port, no, when this air will come inside this pump, inside this air motor through this inlet port, no, that time its pressure is going to exert equally on this all direction, getting it? And each when you can assume the position number one, position number two, this position, and the rotor turns continuously due to this pressure of this your air, okay, compressed air. And this pressure energy of this your compressed air is going to convert it into the kinetic energy in the form of your rotary motion and the your force. Okay, and this air is when this air at a reduced pressure, no, that when it reduced pressure will achieve, no, that time through this exhaust exhaust port, your air at reduced pressure will be exhausted to your atmosphere by this exhauster port. Okay, and this shaft of your motor is actually it is connected to the unit, to the your that actuator part. Okay, so same design of this air type motor actually are capable of providing rotation in either direction. Okay, uh, it may be your clockwise direction rotation or the anti-clockwise direction, getting it? So this is a construction of your vent type of air motor, but here some limitation is there. Okay, one first is the here you will get the noise operation. Okay, so what are the air exhausting from the motor, no, so that actually create unpleasant sound. Okay, that means noise. Okay, due to that only it is actually it is uh, recommended that to use the muffler. Okay, and due to that muffler, uh, this unpleasant sound that will be absorbed by that muffler. So noise operation somewhat will be produced through this wind type of air motor. And second is non-precise motion. Okay, so in applications where high precise motion is required, no, so that time this air motor is not suitable due to that compressibility of the your ear, getting it, compressibility of the your ear. So this is a this is a ear vane type ear motor. Understood? Understood or not? Vane type of ear motor. Whatever the we have discussed, that vane pump, vane hydraulic motor, same construction operation is there, but the difference is that only here the fluid will be the compressed air. Understood or not? Understood or not? Please tell me. Please reply me. Please reply me. Okay, just a minute. I will just check whether any video is available for this vent type. Okay, and actually this is your continuous type, continuous rotation type of ear motor. Okay, just quick. One minute. Just a minute. Actually, this is a vane pump, but you can see the similar construction is there. Okay, here fluid is there, but here is used for the vane air pump. Okay, so you can see
containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid during half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are gear pumps,
The pistons are arranged like wheel spokes around a cylinder.
see whatever the air motor is there. We have discussed that vane.
Like wheel spokes around a cylinder block with an eccentric central cam mounted on a drive shaft. Radial pumps are designed so the pistons stroke in a direction at right angles to the shaft.
Air motor. Okay, same is there. See.
The pistons are arranged like wheel spokes around a cylinder block with an eccentric central cam mounted on a drive shaft. As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help ensure that fluid only enters the inlet ports at low speeds.
Design of a rotary actuator consists of a short cylindrical chamber enclosing a vane fixed to a central shaft and a shoe, which partitions the chamber into compartments on either side of the vane. The chamber is formed by a body bore closed at each end by a head, which supports the shaft assembly in an anti-friction bearing. Specially compounded seals help prevent leakage past the shoe and vane. A fluid pressure differential between the chamber compartment acts upon the vane to cause shaft rotation through an arc. The majority of rotary actuators are constructed with 1 or 2 vanes, but they are available with 3 or more vanes for special applications. The rotary actuator, simple and efficient.
In pneumatics, cylinders belong,
especially for expensive cylinders. Right-hand chamber.
No, I think this video.
But the cycle life is limited by the wear of.
Pneumatics here is a 5-point direction, which we can observe in the energy. The vertical force of actuator applied by total area of piston. The diameter of rod and length of
This actuator stem to move. Card produces a 4 to 20 an actuator receives vane style and the rack and pinion style. Want to learn PLC Pro? Okay, let's review what we've discussed. Energy, linear motion, rotary and linear pneumatic actuators are operating energy source. A rotary motion. Let's look at some examples of how rotary and linear pneumatic actuators are operated, as there are
How you
many
will
different types of each.
linear
In the
pneumatic
rotary pneumatic actuator category, the vane style and the rack and pinion style are very common.
rotary.
Vane actuators have a cylindrical chamber in which a movable vane is mounted on a shaft. Pneumatic air under pressure applied on one side of the vane causes it to rotate through its stroke. Rack and pinion actuators use a piston attached to rack gear. When pneumatic pressure is applied, the piston and rack move linearly, rotating the pinion gear and drive shaft. In the linear pneumatic actuator category, the spring diaphragm style and the piston style are very common. The piston style pneumatic actuator utilizes a piston inside a cylinder. The movement of the piston is caused by applying pneumatic pressure, thereby moving the piston upwards. Removing the pneumatic pressure causes the piston to move downward due to the pressure of the spring. This motion is referred to as air to retract. An air to extend motion can also be achieved by common actuator used consists of a diaphragm, pneumatic pressure, body, spring, and opens the valve. Let's look at a typical. The PLC analog output card produces a 4 to 20 milliamp current.
Now, one point we have discussed in the last lecture, the application. Okay, in the I think first lecture, application of pneumatic strip. So with the help of one small video, here
in this video, I discuss the application of pneumatic system.
Already
So
application
of the pneumatic system is for a various pneumatic tools, like as the in drilling machine, screwdriver, nut runners, and the jackhammers. Out of this, here you see this image of the screwdrivers. It is generally open to tight or loose the bolt, okay, and it is runs by using the compressed air. So that's why it is called as the pneumatic tools or a pneumatic systems. Second one is the material handling and robotics. That is different type of claps, conveyor used for material handling, counters, and robotics arm for a material handling. Okay, so here I show you this image of this robotics arm. Okay, it is used to transfer the material from one place to another, that is on certain area. Okay, this is also a material handling system. So here it use read here, that is a vacuum conveying. Okay, so by using the vacuum, the material is transferred. So here they fill the materials and it is transferred to this place. Okay, similarly the pressurized conveying by using the pressure. Okay, so here you see that blower is installed at that type here. Okay, at the outlet portion. So this due to blower is put at here, so vacuum is created in this full system. In this pressurized system, you see blower is put at here, so they create the pressure, and due to pressure the material is transferred from this place to this tank.
See, this
here you also see the one another image. The material is transferred from that is in agriculture. This material is directly transferred from this place to this site. Okay, by using this compressed air or by using the compressor or by using the pneumatic systems. Now before moving it, I request to like the video. Packing system. Okay, so packing is the final operation done on the product in any industries. So every industries produce some product and its final product is completed by using the packing. Okay, and packing should be as fast as possible, and almost all the packing machines are the pneumatic systems. Okay, so generally you see this is the packing machines of the some grocery product.
Due to this,
so all that purpose the pneumatic packing machine is used.
Okay. Are used, no? So due to that only, I'm
Next
sharing.
one is for the mining operations. So we all know that during the mining, there is a various flammable gases are involved from the earth during the minings. Okay, and due to this presence of explosive in the mines, electric device shall not be used. Okay, because in the mines there is a flammable gases as well as the explosives are there. Okay, so by suppose we use the electric system and some spark is occurs, then the lots of possibility of the fire. Okay, so because the spark is produced by them and may cause the explosions and fire hazards. Hence, pneumatic hand tools are externally employed in the or used in a mines. Okay, so someone feel that questions that in a pneumatic system we also use the compressor, and for run the compressor we require the electric motors. Okay, but we put these electric motor and compressors outside the mine. Okay, and only compressed air is supplied inside the mines when the cavities are created. Okay, so they are avoid the fire hazards. So you see that is a various these type of the tools and some of the explosives are used.
We have seen that type of.
Next, it is used in automobiles. Okay, so in automobiles there is a number of the component that work by using the hydraulic systems as well as the pneumatic systems. Okay, so here we written the air brake. So similar application we see in a hydraulic system. Okay, that is a hydraulic brake is already available. Okay, so in some vehicles the pneumatic brake is used. Then the air suspension system, automatic doors, wipers and cushions. Next one is the machine tools. So in a different industries that is a various machine is used. Okay. So out of the machines, the some are the pneumatically operated machines, like as the pneumatic press, pneumatic drilling machines, clips and vice. So here I show you some vice that is a pneumatically operated. Okay, here you see that is the opening is provided. So here from this place the compressed air is supplies and this vice is operated. So generally use it the manually operated vice. Okay, but this is operated by using the pneumatic system, means by using the compressed air. This is another type of the pneumatic vice. And the medicals and dental equipments. So in dental chair, operating tables and dental drills. So in a dental, that is a various equipments by working by using the pneumatic system. Okay, so that is a root canals and different treatments of the dentals are created by using these pneumatic systems.
You can see.
So here you see that is the image of the pneumatic system for the dental purpose.
Available in the hospital dental.
And last one applications is for the agriculture equipments. So in agriculture, shears and pruning machines are used for a different types of the crops. So here you see that it is the various types of the pneumatic machines that is used for the agriculture purpose. So thank you for watching this video. If you learned and like the video, subscribe the channel.
Okay. So that was about our pneumatic actuator air motors. Okay, and with that we have completed or finished our unit number 4. Okay, now do we have we will move further. That is unit number 5. As we have discussed in the unit number 2, that is in the unit number 2 we have discussed the elements and the walls or hydraulic system elements. In that system element we have discussed the intensifier, accumulator, walls, getting it, and the pumps also. So similar to that, you need in this unit number 5 we are going to discuss the remaining elements of the our pneumatic system, that is the filter, regulator and lubricator. And further we will discuss and the most important is the compressor. And then further we are going to discuss the controlling element, okay, fluid power control element, that is the valves. Okay, so whatever the valves we have discussed for the hydraulic system, same valves will be here for this pneumatic system. Okay, in that control valve we have the direction control, flow control and pressure control. Okay, and the most important point for this unit number 5, that is here for the unit for the pneumatic system will have the one separate unit, that is a FRL, filter, regulator and lubricator unit. Okay, this is only, it is used only for this pneumatic system that we are going to discuss. Air compressor is the first topic is there. Okay, for the air compressor also we are going to discuss the its types, working, operation, then how to select. Then we are going to see the FRL unit, okay, filter, regulator and lubricator, FRL. And for this we are going to discuss individual construction, working, operation and then it's a symbol also. And then further we have the piping. Okay, as we know that to transport air from your compressor, because we know that the compressor is the air generation unit, because through that only we'll get the compressed air. So to transport that air from your compressor to the your actuator or the further through that your wall, we need some piping system. So for that piping, which materials we should take, okay, depending on the pressure rating, how should have that piping layout. Okay, that we'll discuss, and then we are going to discuss direction control, flow control, and pressure control. Getting it? Whatever the types of the pumps we have discussed, now the same types of the compressor are there. Okay, so in the next lecture we'll discuss this air compressor, then further part also. Okay, next lecture will start this chapter. Okay, this unit number 5. Okay, now before going further, whatever content, whatever the topic we have discussed up till now, whether it is understood by you all or not, just tell me, understood or not, what are the part we have covered up till now? Please reply me yes, no in the chat box. Okay, so we'll continue this topic in the next lecture. Okay, so I request all of you, please write down your roll number in the chat box. Okay, we'll meet again today at 3:30. Thank you very much. Please write down your roll number in the chat box as attendance.